Hi everyone, my name is Neil Sims and I'm one of the co-chairs of the Group on Earth Observation Land Degradation Neutrality Flagship, and today I'm going to show you some of the challenges that we're facing when we look across the world and try and assess land degradation in different geographies. There's quite a bit of documentation about how the land degradation can be measured using Earth observation technologies in particular, and also some documentation around the framework for land degradation neutrality. Essentially, land degradation neutrality is like a net zero program for land degradation. So if development happens in one land cover type in one area, then an equivalent area should be restored or protected in another area there to balance out the loss due to development with the conservation gains due to the policies that are implemented. There's a couple of good resources here. The good practice guidance document is one that I led out of CSIRO, and that really describes how countries can use Earth observation to map and monitor land degradation in their country. There's recently been an addendum to that which clarifies some issues around what time periods data should be aggregated and how to interpret degradation at the pixel level when changes have occurred in pixel level degradation over time. One of the best resources is on the right hand side there. It's a product I helped put together for the Committee on Earth Observation Satellites, and it really summarizes the indicator, a bit about LDN, and also points to some challenges and data gaps, including some of the things that I'm going to talk to you about today. And there's a link there for you to have a look at later on. Now, just quickly, the indicator itself is the proportion of land that is degraded over total land area. And for the indicator, it's binary. Land is either degraded or it's not. And we determine degradation based on three what we call sub-indicators. So that's land cover and land cover change, land productivity, and carbon stocks above and below ground. There isn't really a good data set for carbon stocks above and below ground available yet, we don't think. And so what we do is replace that with soil organic carbon stock, and I'll show you a bit about that in a few minutes. There are also a number of ways that we interpret the land productivity metrics. For land productivity, we can use something like the Normalized Difference Vegetation Index, NDVI, or any other index. And basically what we do is we look at how the annual measurements of land productivity are changing over a very long time, about 15 years, how recent conditions compare to the remainder of that time series. And also we look spatially to identify any factors that might be reducing productivity spatially in a local area compared to other areas around it. That's called performance. I'll show you a bit about those in a minute. Now, one of the challenges with the land productivity dynamics sub-indicator is that when we envisaged how this might be interpreted, I guess you see this sort of conceptual model on screen there. So there's a dynamic of vegetation productivity over time. It's affected by seasonal factors, rainfall variables, things like this. And you can identify different directions and levels of productivity within that cycle to identify whether a parcel of land, a pixel, is degraded or not. Some of these phases are easier to identify than others. That's okay, and we're working on that. But there are some regions where vegetation cover is very low, for example, and we don't quite get that seasonal dynamic. In Australia, you get a boom and bust dynamic in relation to rainfall, for example. This may also not work in very densely vegetated areas, the tropics, and it also doesn't work well where you can't see the land in areas like the Pacific Islands, for example. So productivity, the direction, the trajectory of productivity and that level are both important for determining whether a pixel is degraded in terms of its land productivity, and there are some challenges in dealing with that just because of the different vegetation cover types and dynamics in different parts of the world. Now here's an example of a challenge that we're facing with soil organic carbon stock. So this shows some images from Australia's national report on indicator 15.3.1 and LDN from 2022. And what you can see in the left-hand side, the area in orange is actually where vegetation cover in Australia is perennially the lowest. So the least vegetation cover for most of the time is in that orange area there. When we look on the right-hand side at the soil organic carbon stock degradation, what we see there is a kind of a mixture of areas that look degraded and areas that look as though they're not degraded, the green parts, and right in that area. And what we think is happening there is the method that is described to identify degradation of soil organic carbon uses a proportional change in carbon stock, 10%. Where land cover is very low, typically soil organic carbon stock levels are also very low. And so a small proportion of a small amount is a very small amount to detect in imagery. And what I think is happening in this region is that we are seeing just errors around the sensitivity of the data and the model to detect degradation in soil organic carbon there. We need to think about how to improve this, and there are ways we can do that statistically and through data as well. One of the other challenges is also, as I showed on my first slide, looking at vegetation productivity dynamics where your plant cover levels are very low. And there are some real challenges that we have in desert countries, for example, where land cover is very low most of the time. Things like the NDVI and many other indexes do not work very well under those circumstances. There is a new product that is becoming increasingly available globally, which is the fractional cover product. And what this does, it interprets plant cover in terms of the proportion of bare soil, green photosynthetic vegetation, and non-green senescent vegetation within each pixel. That triangle there is actually the legend for this map. And you can see on the right-hand side there, those combinations of green vegetation, senescent vegetation, and bare soil are very apparent in those colour differences. This seems to be a much more robust way to represent changes in plant cover in areas where cover is low. What we haven't done yet is really explored exactly how to interpret time series of fractional cover data for land degradation assessment. So that's something that we want to do, especially for those low cover countries. I mentioned some of the challenges that we have with small islands previously. That graph on the left-hand side there was something done by CSIRO for us. It shows essentially the proportion of cloudy days over a range of Pacific small islands, and basically many of them are covered by clouds much of the time. That poses a real problem for the use of optical data sets, of course, where you don't get that many opportunities to actually measure changes in the land surface. Another challenge with those data sets is that we provide default data sets for reporting at the global level, and these have quite large pixels, about 100 meters or larger, and of course they are also not quite right for use for planning or monitoring the distribution and dynamics of land degradation in very small countries. So on the right hand side there, Apacheta are one of our partners in the GeoLDN flagship, and they have just facilitated the production of some new data sets basically that compile the high resolution imagery available over SIDS in the Pacific and elsewhere, as you can see. So that's a great new product there. There is actually now quite a bit of focus on producing data sets for the small island developing states. Now there's a lot of other data sets that we could use too, and some of them provide different opportunities to see different elements of land productivity, dynamics that saw carbon improve our land cover classifications, and we're exploring how to use those right now. There's a couple of great new hyperspectral satellites which let us untangle the contents of pixels in much more detail than we can with multispectral data. One in particular called Emit, I think, is producing some really good results at the moment. That's a NASA product, a NASA sensor on the space station. There's lots we can do there. High spatial resolution imagery are becoming more common. There is some challenges associated with high resolution data, which is that they take up a lot more data volume, and also it can complicate locational accuracy issues in some circumstances, particularly if you're out in the field and you want to locate yourself within a specific pixel using a GPS for field work, for example. That can be more difficult when pixels become smaller. There's going to be a lot of opportunities to capture data more frequently using a lot of systems that are coming online now. There's, small sat constellations, Starlink, for example. If they had cameras on there, then maybe that'd be a great thing. So the increase in frequency will give us a better chance to capture the peak productivity, for example, in many areas. With a 16-day repeat cycle like Landsat has, for example, at the moment, you can often overlook or miss that time when productivity is at its peak. So more frequent views would be good. There's some great new thermal data sets coming online, and this might help us work out ways to assess degradation in urban areas, the heat island effect, but also in deserts, for example, where cover remains very low, but there may be changes in moisture levels, for example, in the ground due to works that are ongoing in that country or that region, which may reduce surface temperatures and start heading in a sort of a more livable direction. Lots to do there in terms of untangling how the thermal data can be used to assess land degradation. And one of my favourite potentials is with synthetic aperture radar data. This can see through the clouds, and we're getting many more options for wavelengths and systems and sensors and data providers in the synthetic aperture radar space now. I happen to think that being able to see through the clouds may be just as useful for the SIDS, the small island developing states, as having high resolution data, for example. There's also opportunities with SAR to look really at vegetation cover dynamics, and if you combine the wavelengths cleverly, then we might be able to look at changes in vertical vegetation profiles, which could help us understand more about where a forest is being degraded by clearing underneath the canopy, for example. That can be very difficult to map using optical data, and maybe by combining wavelengths of SAR we can get some more information about that. Also, again, some moisture availability sensitivity, which could be good for the desert areas, very dry areas. So lots to do there, a very exciting time for the synthetic aperture radar data. Now, I just wanted to leave you with this last spruik for the Geo Land Degradation Neutrality flagship. Some of you may already be aware of us and have connected up through to us in various countries of the world. One of the highlights that we have is that we've been running dialogue forums where we invite representatives of many countries to come and share their experiences in dealing with land degradation and share their knowledge on how to plan and address land degradation in their countries. These have been fantastic exercises, and one where countries learn as much about land degradation from us as we do from them. It's a really wonderful exchange. There is also some tools available on the GeoLDN website, and on the right-hand side there is a bit of a description of a thing called the LDN Toolbox, which is a collection of curated data sets and analytics systems designed and compiled to help countries map, measure, monitor and report on land degradation in a way that is consistent with the UN SDG reporting requirements, but also helps meet the needs of the specific geography that the country is trying to report on. There has been a great incentive, an interest in making sure that the global reporting mechanisms are adapted by countries to meet their own needs, and so we're trying to support that there. So many thanks to you all for your time. The best way to get in touch with me at the moment is at this email address. Very happy to answer any more questions, and please look forward to hearing from you. I hope the conference is a great success. Thank you very much.